directions of trigonometry. Okay? So, a bearing, the first method, let's even call it the first method, always starts due north. You're always starting with a due north line. Okay? Then we are going however many degrees it says. So if it says a bearing, that's an R of 285 degrees. You're starting due north. We are going from that line 285. So I've gone past that. I've gone past 270. Somewhere here, this direction. So if you are going on a bearing of 285 degrees, you are going right here is the direction you're going. You're really starting at this point, going that direction, 285 degrees. Okay, can you draw that bearing? If there are no letters, no numbers with it, it is simply you're going that bearing. Okay, so let's draw. Our radar stations A and B are on an east-west line. Okay, so radar stations A and B. So if this is A, over here is B, they're directly east and west from each other. We're going to pretend that's a straight line. Okay, so they're on an east-west line. Okay, and they're 3.7 kilometers apart. So from A to B is 3.7 kilometers. Station A detects a plane at a point C. Okay. So Station A detects a plane at point C on a bearing of 61 degrees. So from A, there's a plane that they spot at 61 degrees. From A, there's a north. Does everybody see the north line? Here's our north. So from Station A, where's a 61 degree bearing? It's gone this direction. We're going to pretend this is 61 degrees. So right here, 61 degrees. And there's a point C that plane is there. And it says Station B simultaneously detects the same plane on a bearing of 331. So new north line from B. So here's our north line from B. So where is that? Where is that bearing of 331 degrees? So north, it's going all the way 180 to 70. Ooh, a lot. Not quite. Oh, we're going to pretend that this connects. We'll just have to erase a little bit. This, I'm still on eraser. This line is going to connect to this line. And we have our point C. This red is a 331 degree bearing. Now, the first and key part of all of this is drawing it. Having a correct sketch. Does it have to be perfectly 61 degrees? I guarantee that's not a perfect 61 degrees, I can tell. Okay? Does it have to be a perfect 331? No. Okay? I don't know. But there's some pieces of this that we need to be able to find. Okay? And the way they're asking a question. Find the distance from A to C. How can we find the distance from A to C? I really don't know a whole lot about this. Okay? What are some pieces that you can determine? North and east. How many degrees is this right here?
90.
It's 90. A north line and an east line will always hit at a 90 degree angle. So can you find what this measure is? It is not draw the scale. Right? So how did I find 29 degrees? 90 minus 61, they're complementary angles. Okay? Over here, this red. How can I find this interior piece? We know all the exterior. How can I find the interior? How can I find this little piece? You can say 231 minus 270. Why is that? Because so this is 90, 90, 90. So that's all the way to 270. So what's 331 minus 270? 61 degrees. They're what? Complementary. So what do you know about angle C? Yes, because these two right here, 61 and 29, are 90. What's left? 90 more. Angle C is a right angle. Wow, could not have imagined that would come out like that. Wait, maybe I could have. This is Trig, and we only talk about right now right triangles. It has to. Okay, it has to come out like that. Okay, so now we have all our angles in our triangle. What side length do we have? 3.7. You have the hypotenuse. So this is our hypotenuse. Can you find A to C? Oh, that was an awful line. Can you find A to C? Solving your triangles, they're only asking for one piece. So what are you going to use? Sine. Opposite over hypotenuse. Did anybody think about using cosine? Could you use cosine 29 equals x over 3.7? Will they be the same?
Yeah.
Why?
Because math.
Uh,
Well, because like cosine is oh, because the sine squared plus the cosine squared equals 1 or something to do with that. They're like 90 if you add those two.
So they're complementary. So sine and cosine are co-functions. They're co-functions. So what is?
Wait, how do you know that you're finding it out of 16? Did you just before?
Yeah. Yeah, I mean, they use 61 because he picked this angle right here.
Okay.
And you did opposite over there. If you wanted to use cosine, you thought cosine?
Okay.
Cosine is adjacent over hypotenuse, so I would use 29.
Okay.
But these two will have to come out equal. Have to. Because they're cosine.
Yeah.
All right, so what did you get for A to C?
3.2.
3.2. 0.2 what? Kilometers. Okay, 3.2 kilometers. Their next little red box that says caution. A correctly labeled sketch is crucial. Crucial when solving applications like this. Some of the necessary information is often not directly stated in the problem, but can be determined only from the sketch. Like this 29 and 61, finding that that is a right triangle. Okay, you have to be able to do that. Okay, do we need to work one more example? Yes, let's do it. One more example like this before we move on to second method. Radar stations A and B are on an east-west line. Starts the same thing. Radar stations A and B are on an east-west line. And they are 8.6 kilometers apart. Station A detects plane at C, on a bearing of 53 degrees. So I'm just going to write those. 53 degrees from station A. And station B simultaneously detects the same plane on a bearing of 323. Find the distance from B to C. There were the bearings from station A. So, station A saw plane C at a bearing of 53 degrees. Station B saw the same plane simultaneously at a bearing of 323 degrees.
What's the angle?
What are the angles? That's the big question. So this one is the 323.
And then you gotta flip it.
What's that angle? What's that angle?
No, but I thought you said that you wanted us to use both of them as bearings. Or you just
They are. This is a bearing from station A. There's A. This is station B. So this is the bearing from station B. So there are two bearings. They're from different places. One's from station A, and one's from station B. It's still very much like this one. Okay, I did not move on. I have extra examples in my book. I have an extra example for every example that I give in your book. I have another one.
Was this a sketch?
I would love to see your sketch. Yes.
If it doesn't.
No, it's okay if they don't turn out like perfectly drawn to
It
scale.
doesn't look that right.
But it still is. It's okay.
And if I draw and it doesn't look right, is it okay?
Yes, but because did you see mine? The last one?
Yes.
No. There was no way that was 61 degrees and that was 29.
That's still bad.
Not drawn to scale was my motto for several years. Probably still is my motto. Okay, do we have a sketch?
see.
Yeah. Okay. Okay, so station A and station B are east-west line, 8.6 kilometers apart. From station A, they see a plane at point C at a bearing of 53 degrees. And so the 53 degrees goes near A. They see the same plane from station B on a bearing of 323 degrees. Yes. Like you're a little bit off.
I was looking at that.
Yeah, that's all. We're not next. We're not started. That's number 2.
Yeah, I don't know why I did that.
We're not doing that.
It's like I did with my cat yesterday. I got it.
north line here. 53 degrees, so it's a little more than half. And there's a plane C. And from B, our line is going 323 degrees. So what pieces can you find? Can you find this little piece? What is it? 37 degrees. Going over here, if this is 323 and we're subtracting 270 from it, should everybody get 53 degrees?
I have a question.
Yes, ma'am.
Will those two angles always be the same?
Now, are you asking me, will this angle and this angle always be complementary? Yes. For now. So I can't say always. So for now, yes, they will.
I was asking about.
Okay, if these two angles are complementary, these two angles are complementary. This goes back to geometry. The same angle is complementary to this other same angle.
Why doesn't that?
Then they will be equal. Do what?
Why doesn't the other?
Are you asking me? This angle right here is guess what? How much?
37. But why does it just say that? Like, why do we have to use bearings?
Because that's what planes fly on. Okay? Planes, ships. In the real world, this is what's going to be happening. Actually, it is more complicated than this, but this is kind of old school what they did. Because there was just one number. Okay? And right now, for you to figure it out, the book has been nice enough to give you right angles. Okay? Eventually in Trig, yes, they won't be. And then it's important for you not just to make an assumption that it's going to be. Right now, you can make an assumption it's going to be a right angle. Yes, it will work out in this chapter. It's beautiful. Later on, it will not be. Okay? So, you have to figure out what these are. Right now, it's easy to figure out that they're complementary, they have to be a right triangle, all is well in the world. So, what are we looking for? B to C. So, there's our unknown. So, we have the hypotenuse. Which one are you using? Okay, so sine what? 37 equals x over 8.6. Or, could we use cosine? 53 is x over 8.6. Either way, you should get the same thing. Right?
Yes.
What do we get? 5.2 kilometers. Okay, so what's the distance from B to C? And what are that, which one did you find? Did you find A to C? Did you find B to C? Should B to C be the shortest side length? It has to be. All right. Can we move on to the second method? Mark 2 problems can be done. Gosh, we don't have time for this. Okay.
Don't you love Wednesday schedules?
And so much more. All right, second method. They're going to give you two directions, a southeast. From the bearing, let's first just draw some. We don't know. Can you draw a bearing of north 42 degrees east? North 42 degrees east. North is where we're starting. We're going 42 degrees toward the east. So maybe you need to know to never eat soggy waffles on the compass.
Soggy waffles? Never heard that. I've always heard never eat sour watermelon.
That's a good one too.
That's what I've always heard.
Okay, we all have different things.
Soggy
Okay,
waffles,
so
what?
we're starting
I'm
north.
shook.
Which way are we
I've
going?
never heard this.
East. So where's 42 degrees? East. So we're going 42 degrees toward the east. That's your bearing. If we are going south, 22 degrees east, what does that look like? We're starting from south. Okay, hint with the second method, you will never have a number more than 90. It will always be an acute angle. Okay, with the first method it wasn't. This is the second method. That will give you two pieces. So what is south? 22 degrees east. So we're starting from the south position. We are going 22 degrees east. Okay. I'm going to try to get one more on this page. I'm going to just do, try to get two more. Can you go north? 18 degrees west. So you're going northwest, essentially, but it's 18 degrees. So we start north, which direction is west, left. We're only going 18 degrees. So this little piece from here to here is 18 degrees. But this is where we're starting. We're always starting at the vertex. Okay? So if someone is traveling north, 18 degrees west, that's the bearing they're going on. Last but not least, could we have south? South, let's say 75 degrees west. Where are we starting at? South. So there's south and then 75 degrees in the west direction. Okay, does that make sense?
Yes.
All right, so drawing them is the first key. First key is, can you draw them? And I even think on the first quiz that we have, I only have you drawing them. I don't throw out an application, can you draw it, and find distances and all that kind of stuff yet. Okay? So, but there are applications. This is all about application of. The bearing from A to C is south 52 degrees east. So from A to C, so start some point A. So from A to a point C is south 52 degrees east. So I'm drawing, so here's my south line. Let's say south 52 degrees east. This is the one in your book. So can we draw south and then 52 degrees east? Here we go. There's a point C over here. It's 52 degrees. The bearing from A to B is north, 84 degrees east. So we're starting from A again. But this time we're going north, 38 degrees, 20, the bearing from A to B is 84 degrees east. Oh my word, there's too many numbers. I'm trying to look at too much stuff. The bearing from A to B is north, 84 degrees east. So from the same point A, we're going north, but now east 84 degrees. Not quite 90, but somewhat close.
Do you have to find like what that angle is?
Okay. I'm just drawing it first. Okay? The bearing from B to C, so now we're going from B to C, is south 38 degrees west. So from B, I have a south line. And then 38 degrees. Not drawn to scale. I'm going to put point C a little bit more that way because I was really not going to be to scale. So this is 38. A plane is flying at 250 miles per hour. Takes 2.4 hours to go from A to B. Find the distance from A to C. Okay, so a plane is on the bearing from A to B. So plane is flying, however you want to draw a plane, at at 250 miles per hour. And he flew for 2.4 hours. Can you find the distance from A to B? Good. Okay. Maybe we'll do side links next.
You want the time?
No, I know what the time. 2.4 hours. How far did he go?
What's the
Okay.
250?
250 miles per hour at 2.4 hours. You simply just multiply them.
600 miles.
Is that 600 miles? So from A to B is 600 miles. Now, inside here, can we find our angles?
Yes.
This, I think, is the easiest one to find right here. So, north-south is 180.
So you would add,
No.
you would add the
37.
84 and 52, then subtract that.
38.
They have to add up to 180, right? This line right here is 180 degrees.
Oh.
We have 84 and 52. So when you subtract, what did it become?
44.
44 degrees. Now, question. If we're going east, oh, that's not what I wanted to do. Stop. No, I know, because we're out of time. I'm sorry, I didn't mean you to stop. If we're going straight north, if there's this north-south line, can you find this angle up here?
Is it gonna be supplementary to 84? No.
No. Actually, it will be.
Yeah.
It will be because they have to be. So this total thing has to be a total of 84. Yes,
Yeah, Molly.
it does. I don't always think of it like that. So then you have 96 and 38, and what is the middle piece?
Yep.
Ends up being 46 degrees. This down here ends up being a right angle. Imagine that. Okay. Can you find the distance from B to C? From A to C, I'm sorry.
We don't have homework, right?
You can finish this problem. How about that? Find the distance from A to C. Whew.
Oh, actually, I'm very different about the zakat and the shahaba and the salat. And the
Oh, I gotta stop recording.